So here we have a representative TCID50 assay with pictures from an actual plate that's been joined together, various different wells. And if you remember from lecture, when we have the presence of virus, it'll stick to red blood cells and it'll prevent them from falling through gravity. And you can see that up here in 7 and 8, the virus is not allowing that red blood cells to button and fall down. You can see in 9 and 10, you have a button present. And that means there's no virus present within these wells, okay? So assuming that 9 and 10 are a negative control, we can see throughout our dilutions, there's a bunch of buttons. And so there's no virus, which is what we'd expect with a negative control, okay? Looking at the rest of the plate, we have one sample that's 1 through 4, and we have another sample that's 5 through 8. Both of these samples have been diluted tenfold down the plate. With the first well, it's been diluted tenfold, second well, 100, next well, 1,000, and so on down the plate, okay? And so the first thing we have to do is we have to calculate how many of these individual dilutions are infected, okay? So if we go over here for this first sample, and we do the 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, and 10 to the negative 5, okay? We can see that that is where the virus stops, is between the 10 to the negative 4 and 10 to the negative 5, okay? So we need to calculate the percentage of wells that are infected. So for up here, we have 4 out of 4. For the next one, we have another 4 out of 4. For 10 to the 3, we have 4 out of 4. For 10 to the 5 or 10 to the 4, we have 4 out of 4. For 10 to the 5, we have 0 out of 4. Okay? And so we have 100%, we have 100%, we have 100%, we have 100%, and we have 0%. Okay? So the next thing we need to do is we need to calculate that proportionate distance for the TCID50 using the formula that you had in lecture. And if you remember that, what we're going to do is we're going to find where 50% falls. 50% falls between 100% and 0%, okay? And so those are the two values that we're going to need. So with the formula, what we're going to do is we're going to take that first one above 50, and we're going to subtract it from 50, okay? And then we're going to divide that by the next, or by the 100%, the one that's right above 50. And that one is going to be subtracted by the next one below 50%. In this case, it's 0. So what we're going to end up with is 50 divided by 100, which equals 0.5. Okay? The next thing we need to do is we need to determine the dilution that was right above that 50%. And so in this case, it's 10 to the negative 4. But we're going to take the inverse of that. And so we have 10 to the 4th. And here what we're going to do is we have to add that PD value that we calculated to that 10 to the 4th. So that's going to be that 0.4, or that 4 times, or plus 0.5. And so what we're going to end up with is 10 to 4.5, which is equal to 31622. Okay, now most of these assays have utilized 100 microliters as their viral inoculum all throughout the plate. And so our answer here is not quite correct because it's not per mil. And so what we need to do is then we need to divide that by 0.1, okay? Because 100 microliters is 0.1 of a mil. And then what we end up with is 316,220 TCID50 per mil, or 3.2 times 10 to the 5th per mil. Okay? And so if we go back to the sample, or the second sample, we can see that there's a slightly different titer here. Okay? So we have to do the same thing. We have to calculate how many of the wells are infected per dilution. And so, running all the way down, we can see that this one is slightly different in that when we get to the 10 to the 6th, not all of these wells are infected. 3 of them are not, 1 of them is. Okay? And so we're going to have to calculate the percent all the way down to 10 to the 7th, because that's where we have a 0. So there's no wells here that are infected. So going back, we have 10 to the negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7. Okay? So, up in the negative 1, we have 4 out of 4. Negative 2, 4 out of 4. Negative 3, 4 out of 4. Negative 4, 4 out of 4. Negative 5, 4 out of 4. Negative 6, we have 1 out of 4 are positive for flu. And then in the 10 to the negative 6, or excuse me, 10 to the negative 7, we have 0, okay? 0 out of 4. So we have 100, 100, 100, 100, 100, 25, and 0, okay? Now remember, the next thing we need to do is we need to determine that PD value. And so we need to find out, where does 50% fall? 50% falls between 100 and 25. So 50 or 100 is the next above 50. So it's going to be 100 minus 50 divided by that 100, because that's the next above 50, minus the next one below 50, which is 25. Okay? And so what you're going to end up with is 50 over 75. Okay? And that's going to equal 0.66. Okay? So next thing we need to do is we need to go back and find the dilution that is between, or is the next highest above 50. And we can see in this case, it's that negative 5. So we're going to take the reciprocal of that, so 10 to the 5th, and we have to add that 0.66, okay? And so what we then need to do is, it's going to be 10 to the power of 5.66, okay? And so you're going to use your calculator to calculate that. And then if you remember, this is 100 microliters per well, and so you're also going to have to divide that by that 0.1 to get your total TCID50 per mil. Okay, hopefully that is clear, and hopefully you can do your homework. And if you have any issues, go ahead and let the TA or myself know. We can help you out.